Good morning, everyone. I'm James Lester B. Colle from DCPET 31. In today's digital world, computers and smartphones play a crucial role in our daily lives. At the core of these devices is the central processing unit, or mas kilalang CPU, often called the brain of the computer. It executes instruction, processing data, and ensuring that all tasks run efficiently. In this video, we will explore or we will tackle about how CPUs work, how evolution of CPU technology, the role of GPUs and how they differ from CPUs, the SAP1 or simple as possible architecture and its operations, and the basic programming concept for SAP1 and for future eh, for future reference or technology rin po. First po, how the CPU works. What is CPU? A CPU or a central processing unit is the main processor of computer that executes instruction and processes data. It follows a cycle called the fetch, decode, execute cycle. To carry out operation, the fetch, decode, execute cycle. First, fetch. The CPU retrieves an instruction from memory or RAM. To decode. The instruction is interpreted to, to determine the required operation. 3. Execute. The operation is performed by calculation, moving data. Main component Main components of CPU. First, arithmetic logic unit or ALU performs mathematical and logical operations. 2. Control unit manages and directs data flow within the CPU. 3. Registers small high-speed storage for temporary data storage during processing. Clock synchronizes the CPU's operation measured in gigahertz. Cache memory stores frequently used instruction for quick access, reducing need to access lower main memory. Types of CPU. Ang andito po is SI, or Complex Instruction Set Computing. Uses complex multi-step instruction to perform tasks efficiently. RISC, Reduced Instruction Set Computing, uses s- this this RISC po uses simple, fast instruction that execute in a single cycle, improving performance. Hybrid architect. Ang next po is hybrid architectures. We have combining elements of CISC and RISC to optimize performance and power efficiently. Next po is factors affecting CPU performance. Clock speed. Higher speed allows for more instruction per second. Number of cores. More cores enable parallel execution of tasks. Cache, cache size. Larger cache improve data access times. Power consumption. Efficient designs balance performance and energy use. Factors affecting CPU performance ay yun. Ang nadagdag lang po siguro is dalawa po pa nalagay ko. Yun po yung power consumption, efficient designs, balance, performance, and energy use, thermal management, advanced cooling system, prevent overheating and performance throttling. Ito po yung mga kadalasan pong nakikita pag bumabagal na po yung laptop po. Yun po yung katulad po ng tuyo na po yung thermal paste or yung cache size din po. Yung kadalasan po sa ibang laptop is hindi po ano tawag dito? Hindi po pinapatay. Minsan po nag-FPS drop. Yan. Pero kadalasan ko pong nakikita is yung thermal management po. Kadalasan po sa atin is nag-overheat. Kaya pag may laptop po, yung iba po bumibili po ng laptop yung laptop na may fan para po maiwasan yung overheat. Next po is evolution of the CPU. CPUs have gone through several stages of development, from early simple designs to modern high-speed processors. In early CPUs po, 1970s to 1980s, ang first po is Intel 4004 in 1971. The first microprocessor capable of executing 60,000 instructions per second. Next po is Intel 8086 in 1978. The foundation of the times x86 architecture or times 86 architecture used in early personal computers. Next po is 8-bit and 16-bit processor allowed for improved computing capabilities compared to earlier models. Next po is MOS 6502 and Z8 po. Popular in early home computers and gaming console. Next po is advancement in the 1990s. The rise of 32-bit processor, which allowed computers to handle more data and memory. Introduction of multitasking, allowing multiple programs to run simultaneously. Next, Intel Pentium Series 1993. Improve processing power and introduce a superscalar execution. PowerPC processor used in Apple computers, known for their RISC-based design. MMX technology introduced to enhance multimedia processing. Evolution of the CPU. Modern CPU. Ito pa rin po pala. Modern CPUs po for 2000 to present po. Multi-core processor. CPUs now have multiple cores, allowing them to perform tasks in parallel. 64-bit architecture allows computers to handle large amount of RAM efficiently. Intel Core series and AMD Ryzen, the latest generation of CPUs optimized for gaming, AI, and high-performance computing. Hyperthreading and simultaneous multithreading, or SMT, enhances parallel execution of processes. Integrated graphics processing, improve graph graphical capabilities without dedicated GPUs. Virtualization support enable better performance in running multiple operating systems simultaneously. Present and future CPU technologies. AR, ARM processor used in mobile devices and Apple M series chips, quantum computing, research and advancement in next-gen computing architectures, AI and neural processing unit (NPUs) designed for machine learning and AI acceleration, energy efficient CPUs designed for sustainability and reduced power consumption, chiplet architecture using modular design for better scalability and efficiency, optical computing and nanotechnology, future innovation aimed at breaking traditional silicon limitation. Overview of GPUs or graphic processing unit. What is GPU? A GPU, graphic processing unit, is a specialized processing designed to handle graphical computation and parallel processing tasks. Difference between CPU and GPU. For feature po, optimized for, ang CPU po is general purpose computing, and for CPU, graphics, AI, and parallel tasks. For cores naman po, ang CPU po ay fewer and more powerful cores. For GPU naman po is thousand of smaller cores. For processing style naman po, ang CPU are sequential processing, habang ang GPU naman po are parallel processing. Ang use cases naman po is for CPU, operating systems, applications, calculations, habang ang GPU naman po ay gaming, AI, 3D rendering, video processing. Ang nakalimutan ko rin po pala, for dito naman po, or pag mas mataas naman po yung mga gamit po natin, katulad po ng ibang laptop na may ay good po for gaming, iba naman po is good po for 3D rendering ka. Pero karamihan po, laging sabay nakikita ko sa laptop is pag maganda po siya pang gaming, is maganda rin po siya sa mga 3D rendering and video processing. Other example of GPUs po, NVIDIA G4 RTX series used in gaming and AR research. AMD Radeon GPUs used for gaming, workstations, and creative applications. Apple M series GPUs integrated into MacBooks for efficient graphics processing. Tesla and AI optimized GPUs excuse po, designed for deep learning and AI acceleration. HPC, high performance computing GPUs used in scientific simulations and weather modeling. Here po we have Intel Core i9 and AMD Ryzen 7. Excuse po. SAP1 operation. Main components of SAP1. Program counter or PC keeps track. Program counter or PC keeps track of which instruction to execute next. Memory address register or MAR hold the address of the instruction being accessed. Instruction register or mas kilala pong IR stores the current instruction being executed. Accumulator or ACC hold the intermediate result of a of calculation. B register used to temporarily store values for stores value for arithmetic operation. Control unit direct the operation of the CPU. ALU or arithmetic logic unit performs addition and subtraction. Output register display the final result po. Dito rin po yung basic or dito rin po yung fetch, decode, execute cycle for how SAP1 execute instruction. First, fetch po. The instruction is retrieved from memory. To decode, the instruction is interpreted. 3. Execute. The instruction is processed and the result is restored or is stored. Ito naman po is SAP1 programming. Example of SAP1 or simple as possible. 1. Program adding two numbers. LDA 0x01 load value from memory address 01 into the accumulator. Add 0x02 add value from memory address 02 to the accumulator. Output the result. Halt the program. Ito pa sa step-by-step execution. LDA 0x01. The CPU loads the value stored at the address 0x01 into the accumulator. Add 0x02. The CPU adds the value stored at the address 0x02 to the accumulator. Out. The final result is transferred to the output register. Halt or HLT. The program stop this execution. Yun po, isa po pala yung real world application. Understanding microprocessor design SAP1 serve as a foundation for studying more complex CPUs architectures. Embedded systems. Basic CPU concepts are crucial in designing efficient embedded application. Performance optimization. Learning CPU structures helps in optimizing software for better execution. In conclusion po, the CPUs is the heart of any computer, executing instructions using the fetch, decode, execute cycle. Over time, CPUs have evolved, introducing multi-core processing, improved memory management, and high-speed computation. GPUs specialize in parallel processing, making them ideal for graphics and AI application. The SAP1 architecture is a simplified CPU model that helps in understanding how a processor works. SAP1 programming involves writing simple machine instruction performing to perform arithmetic and data processing tasks. For the Understanding CPUs and GPUs in basic architectures like SAP1 provides valuable insight into how computers work, whether in gaming, AI, or everyday computing processor continue to evolve shaping the technology around us. Yun lang po. And yun po. Thank you po, sir.